Welcome to my vectors tutorial. Vectors are an important part of doing graphics. We're going to start with the P5 library, yarn add P5 and import P5. It's just a library for working with Canvas and WebGL. It makes it a little bit easier. And we're going to use, I don't like these global variables, so we're going to use the instance mode that I found on the wiki here. So let's go ahead and try that out. So we wrap everything in this sketch function. It takes in a sketch argument. Move that import up and indent this. And this is just equivalent of a hello world. We're just going to draw an ellipse. So that needs to be sketch setup, and we'll make this an arrow function because this is 2018. And we'll just go ahead and actually copy this in here just for this example. And there we go, we got our rectangle actually. So that's equivalent of our hello world, and we can play around with that and see it resizes. I'm using Webpack here. So here we have this example with a ball that flies off the edge of the screen. So let's add a little check here. If it's hit the edge, we're going to invert its speed. So you see it just adds the x speed to the x position and the y speed to the y position. And what we're going to say is if the x has hit the width, the right edge, or the 0, the left edge, then invert it. So if it's moving left to right, then it's going to move right to left. It's going to reverse its direction along that axis. So it needs to be s.width, and we need to do the same thing for y. So it hits the bottom edge or top edge. It's going to reverse its y direction or y speed, and y speed will become negative. It's pretty cool. Alright, I think that's enough of that. I hope you agree. So let's move on. A vector, it can mean many things, but we're talking about a Euclidean vector. So this is a concept in mathematics and geometry. It's basically an arrow. It has an x and y position. It goes from 0, 0 to that x, y position, and of course it has a length. And that length can be calculated. The x is like one edge of the triangle, the y is like the other edge, and the hypotenuse is the magnitude or length of your vector. So Pythagorean theorem is what it does under the hood when you calculate that magnitude. So basically it's just like a pair of x and y, or x, y, z if you're in 3D space. So our position, instead of being two separate variables, is now a vector, and our speed, instead of being two separate variables, is now a vector. So instead of adding x and y separately, we can go ahead and, well, first we'll just update this and kind of keep it how we had it. So on a vector like position, you can access .x and .y. So you can do everything that you're used to doing without vectors just by accessing the x property and the y property and using them just like we were before. And I'm missing something here. Okay, position.x and position.y, and we add speed.x and speed.y. And I'm still missing a couple here. Thought I got them all. Okay, there it is. So that should be position.x and position.y. And so we're back to the previous example, but now we're using vectors. So let's clean this up. We can actually do addition with vectors instead of adding them separately. So we can just say position.addSpeed, and it'll add the x's and add the y's for us, or the x's, y's, and z's if we were working in three-dimensional space, but this is just two-dimensional space, so the x's and the y's get added together. And that actually mutates the vector. This gives you, just changes the vector to a new value. So let's draw a line here from 0, 0 to position.x, position.y. So that's actually like our vector. If we were to visualize the arrow or the line, and we can see it has a magnitude, it's how to get to the position of the ball from 0, 0, which is the top left corner. If we drew a line from the ball to the top edge of the screen, it would form a triangle, and we could do Pythagorean theorem. So let's go ahead and add 50 to the y, and you see the line goes below the ball. And if we add 50 to the x, we see it goes to the right of the ball. So again, that's how you visualize like addition with vectors. So we could also subtract from the x, and it'll go to the left of the ball, and subtract from y, and surprise, it goes above the ball. No surprises there, actually. So you can go ahead and play around with this. So let's create a new position, and position dot subtract. This is my first time playing around with this, so I might make mistakes. Position dot subtract, and then we'll subtract a new vector of 50, 0, and let's see if that works. Position dot subtract is not a function. Okay, I think this is position dot sub. Could have fooled me. And that does not appear to be what we want. Let's try let new position equals create vector. We're creating a new vector. And then we'll subtract the position of the ball from that new vector. And see a little dot there in the upper left-hand corner, I think, but let's see. Log new position. Okay, so those are negative values, so those are going to be off of the screen. That's why we're not seeing anything currently. So trying to illustrate addition and subtraction in a visual way here. Let's go ahead and make this sketch.width and sketch.height, and then we're subtracting off the position of the ball. So it's moving inverse from the ball, or backwards from the ball. So as the ball moves right, that line moves left, vice versa. We could add, so we'll start from 0, 0 and add the position, so we arrive at the same position. We could start from the position and then add or subtract. So we'll do sub. And then what do I want to subtract? Let's try this, 50. So it looks like that's subtracted on the x, and then I guess that does y. Yep. So that's just like our addition and subtraction example before, but with vectors. So that's how you do addition and subtraction with vectors. Kind of put this back here, so now it goes along with the bouncing ball. And let's go ahead and log that out and do .mag. So magnitude is the length of the line. So as that line becomes longer, those numbers increase. So again, it's using Pythagorean theorem to calculate the hypotenuse, because that forms a triangle if you were to draw a line from the ball up. So we could do set mag 50, and that fixes it to 50, so the line does not shrink or grow, but it always points to the ball. That's pretty useful. And you can also normalize, which sets the magnitude to 1, and then you could multiply it to 50, which is the same thing as set mag. So if we normalize, it's just going to be this tiny speck, and then we could do multiply and achieve the same effect as set mag, and we could make it longer or shorter than the ball. So we'll illustrate this now. So if we multiply 50, go back to before, now it's longer. If we do 0.5, it'll be half as long.